This series on analyzing the annual results out of looking at upgrades using the ResStock simulation dataset. In the first video, we looked at the baselines that we were using, and in this one, we're looking at the upgrades. So this is for upgrade 1 for Colorado. As in the first video, they all exist in the same folder when you download them. So this is just another one of those CSVs that we're using. Since we're using the same case as Colorado, the building IDs are going to be the same. The difference here is we're looking at upgrade 1. They are divided by each upgrade on its own. This is to limit the amount of data that exists within each file, because as we said, Excel and CSVs, they intend to upload up with data, and that can cause some problems down the line. So they are divided that way, and you can extract results individually. If you are interested in more streamlined or automated processes, I would recommend using languages such as R or Python, which can allow you to automate a lot of these processes. And using the Parquet files that I described before, you could use them with a library such as Arrow to have access to large amounts of data with a much smaller data footprint. So one of the main differences that you'll find in these upgrade files is that they are very similar. You have the inputs, you have the outputs. It's all the same, but you can find an additional set of data on the sides, which is these. So we've looked before at how we can read what's happening at the top. So we have outputs, electricity as our fuel type, close dryer energy consumption, kilowatt hours, and saving. And the new one that we have here is actually savings. So the data sets are very convenient for you to look at in the sense of that, according to the building that we're having, it actually computes the savings themselves for between the upgrade and the baseline that you have over there. That allows you to quantify how much the upgrade is affecting a particular end use here. So we could notice it would have the same naming as before, just with the savings here, which kind of calculates in kilowatt hours, as it says here, the savings that were added to the building or added to the model itself. The ones that are zero either do not exist in this particular model itself, or in a much less likely scenario, they did not have any. And you would have very rare occasions where you would even have some negative values here, which would mean effectively the upgrade had affected it negatively. So this would be effectively just minus 0.2 kilowatt hours in this case, which is pretty small. So this is how we can read them and look at those. Mainly our interest in analysis, if we want to select which upgrade works better for us, would be mainly concentrated around these savings columns. Now, one other thing I wanted to kind of touch on in this as we start to analyze our data set is that some of the questions that came into us is how do we look at the different distributions of the data set that we're looking at? And that is definitely an important part of it. This is a big data set, around 9,500 plus buildings here, at least in this particular case. So usually when we're trying to look at distributions, we could use descriptive statistical tools such as histograms to look at those. But there are better ways to deal with this. So for example, let's take the case of the building types that we're looking at. So let's use the ones here. So in inputs, as in geometry, the building itself, the building type, according to REX, the Residential Energy Consumption Survey, which is deployed by the EIA. So usually when we're looking at something like that, we could use a histogram, but with large data sets sometimes and how Excel works, histograms sometimes might not be the best option. As you see here, this is not very useful or descriptive and might require us to do a lot of work to be able to discern what this is. We have to maybe rebin them in certain ways. So out of the box, this might not be the best option. So one better option that I would definitely recommend for you to use is actually not to rely on the histogram itself, but actually select the column that you want, go to insert, and use either a pivot table or a pivot chart. These are very powerful tools that allow us to look at them and fix a lot of our problems in a much easier way. So if we select pivot chart, we can select it to be in the existing worksheet, but I always recommend having it in a new worksheet. This is better because this already is a big worksheet and has a lot of columns. So let's do it in a new worksheet over here. What we'd get is the table and the pivot chart itself. So all we have to do is select the field that we have in this case and at this point, it just has counted how many of those, which is 9,415 in total. But what we wanted to do is we would like to put it here in the axis for the categories. Effectively, this automatically creates a table for us that shows us the distribution. So these are categorical variables in this particular case. So that means they just can take one particular value. So if it's a mobile home, it's a multifamily with 2-4 units, single family attached, etc. And it just does the counts for all of them, and at the same time it generates for us now what is effectively a frequency chart, or trying to see how they the count of each just in a chart format. Now, one thing you might notice is that we have a blank addition here. Sometimes we would have a weird value that would come up. This can be easily rectified here by selecting something like the row labels that we have over here, taking out blank. This actually updates both the table here and the chart itself. That way we have it. My final recommendation is change this to actually represent what we have. So in this case, we could literally call this building type distribution. And thus we have this ready. We have all the information that we need, both in number format and descriptive format if needed to extract that. Pivot charts and pivot tables are very powerful tools. Pivot tables allow us to build this on its own. Pivot chart does both of them together, so I would recommend this one if needed, but pivot table does that on its own. So that is a very quick and easy way to look at distributions within a variable to understand what we're dealing with in a particular data set.